Good morning, student. Today we'll start kinetic theory of gases. So, before we start, we have to know what do we mean by the kinetic theory of gases. So, we know that all matters is made up of molecules. The molecules of a gas are in a continuous random motion and their velocity depends on the temperature. Now, due to this molecular motion, we can determine various properties of a gas like pressure, temperature, and energy. And this theory is called the kinetic theory of gases. Now, there are some assumptions of kinetic theory of gases. First is all gases consist of molecules and molecules of same gases are identical in all respects. Second is the molecules are in continuous random motion. I mean the molecules are in a straight line. Suppose there are many molecules in a gas and one molecule is moving with a velocity u. Now there are three components, so we can determine the three components of velocity in x, y and z direction. Regarding this, we can write u equal to uxi plus uxy that uzk. So if we take the mod, we can write in such a way. So we have assumed that ux equal to uy equal to uz. So this we can write ux square u square equal to ux square plus uy square plus uz square equal to thrice ux square, that is u square equal to thrice ux square. This is very important that u square equal to thrice you have to keep in mind. Now third is the collision are perfectly elastic. That means their momentum and there is no loss in momentum and kinetic energy. The fourth is the pressure of gas is due to collision of molecules with the wall of the continuous wall of the container. The pressure which is exerted on the walls of the due to the collision of molecules with the walls of the container. The third is the temperature of a gas depends only and only on temperature, not on the nature of the gas. The sixth is the volume occupied by gas molecules is negligible when compared to the volume of gas. if we consider one container, so there are many gas molecules. No, if I accumulate it, if I accumulate all the molecules, then their volume is negligible. If I count the total volume of all the gas molecules is negligible compared to the volume of a gas molecules. This is very much important. Now seventh is there is no intermolecular forces of attraction among molecules. These 6 and 7 points is not valid for the real gases. Now these are the assumptions and postulates. Now after that we come to the kinetic gas equation. Kinetic gas equation is pv equal to 1 by 3 mn urms. That is urms is root mean square velocity of molecules. Here n is number of molecules and m is mass of 1 mole of gas. Now what do you mean by the urms velocity? There are many molecules in a gas. There are many molecules in a gas. So we can write that if one molecule, if we consider the average and take its mean, then we can write urms equal to root over u1 square plus u2 square is equal to n number of molecules divided by n. This is called the urms velocity. Okay, that is root mean square velocity of molecules. Now we will derive this equation pv equal to 1 by 3 mn urms. So here for the derivation of the kinetic energy equation we are considering a cube, and this is suppose this is x axis, y axis and z axis. Now length of each phase is L. The total number of molecules inside this cube is n, small n, and mass of each molecule is m. Now we are considering only one molecule, and we suppose its velocity is u1. So we can determine its three components. Here we are considering only the x direction. If I consider this, if I want to calculate the force on this wall, we can see that if m mass of one particle, means if one molecule collides with this phase, due to elastic motion it returns with the same velocity, and the its initial momentum will be p1 equal to m u1 x1, and its final momentum will be minus m ux1. Now we can determine its change. You can calculate its change of momentum. It will be equal to twice m u1. Now the time during this collision equal delta t equal to twice L by ux1. With this equation we can, with this momentum and change time, we can calculate the force on one molecule. That will be delta p by delta t. So we can find out the force due to one molecule. So then force on n molecule, for the force of one molecule 1 by 3 equal to, you can calculate for different molecules, na? So we can finally we came to the conclusion that Fn equal to 1 by 3 ml into mn, and if we divide it into n and multiply by n, we can write this in terms of, write the force in terms of the RMS velocity. So it will be Fn equal to 1 by 3 mn by L u square RMS. So with this we can determine the force, that is pressure, equal to F by A equal to 1 by 3 mn u square RMS divided by L into L. Area is L square. Area of this wall is L square. So we can write L square equal to 1 by 3 mn u RMS square by B. So we came to the conclusion that BPB